name is Girish. I'm a senior engineer in NetApp. So today I'm going to talk about decentralized apps and also share some of our experiences with using decentralized app in NetApp. So how many of you are familiar with blockchain technology? Can you raise your hands? Oh, I think quite a mixed crowd. So I think this presentation will be useful. So to begin with, actually this is the agenda. So I'm going to introduce at a very high level what is meant by decentralized application. So how is it different from centralized conventional applications? And also then we will try to understand where we can use or where we can apply the decentralized applications, because blockchain is becoming like a trend. Because of the hype being created, it cannot be applied everywhere. So it shouldn't look like it's just now we have a blockchain as a hammer, so every problem shouldn't look like nails. So we'll try to figure out a set of guidelines that has to be applied for this blockchain being used. And next, we'll cover a very high-level overview of decentralized app architecture. Then the next one is actually these applications being deployed on public blockchains. Actually, as enterprise use cases, we deploy it on private or consortium blockchains. So there, how our experiences will be. And later, we'll follow it up by key takeaways. So to begin with, so what is a decentralized application? So decentralized application is nothing but any software, preferably open source software, which actually leverages the blockchain technology. So there is the very high level definition of a decentralized application. So here, what is a blockchain? A blockchain is nothing but it's a ledger of records or ledger of transactions that we can call. So these ledger of records are actually organized into blocks, and these blocks are called as blocks of a blockchain, and these blocks are actually linked together using some kind of cryptographic validation techniques, and hence the term is blockchain. And some of the key unique features of blockchain is actually it is distributed and decentralized. So that's why we call it as distributed ledgers. And one of the key factor for the blockchain is it brings the transparency and resiliency aspects of it. So to begin with, in order to understand at high level, let's compare with regular web applications. In a traditional web applications, as you see, you will have majorly two components, the front-end client and the back-end server. So the front-end interfaces are usually written by HTML, CSS, or JavaScript, and also there is a back-end server which is typically written by popular frameworks like Rail, Node, and Django. And these front-end portion actually interacts with the back-end using typically JSON messages which are passed through the HTTP transport. So in the key thing about this centralized architecture is everything is, the application is managed and centrally. Whereas if you consider a decentralized application, this is also similar to the web architecture. It contains both the front end and the back end portion. Here the back end server portion is actually replaced by the blockchain. So now the front end, which is written using similar the HTML or CSS or JavaScript, it interacts with the back end with the blockchain using the same protocol. So it indirectly means like if there is a decentralized application, so the end user application will not be able to distinguish whether it's really running a web application or the blockchain based application, because the backend is entirely transparent since we are using the same HTTP transport with JSON kind of messages. And the key idea here is this blockchain is going to bring the distributed ledger aspects. So because of these distributed ledger aspects, we have a lot of advantages compared to the traditional web architecture. So for example, in case of centralized architectures, we have it becomes like a single point of failure where everything has to be managed centrally. So there is a scope for data being misused either by internal attacks or external attacks. So because the data as and when it gets accumulated, so it can be either misused by typically what happens is these backend is actually hosted on cloud or some other third party who provides the services, and because of that there is a problem of insider attack or manipulating the data or even monetizing the data without the end user's knowledge. So all these disadvantages we can overcome by making use of a blockchain where that data is actually spread across multiple nodes, and we cannot create a single point of failure scenario because since the application data is present in the distributed ledger, so even if you bring down a single node, still your application will be highly available and resilient. Because of this resiliency and the transparency aspects, I think in future these kind of applications will become more popular. It's not like decentralized applications were not there earlier also, before the blockchain technologies evolved. Earlier we had like BitTorrent, BitMessages kind of applications which are running on peer-to-peer network. So now the blockchain is evolved as a platform for peer-to-peer network-based architecture where it gives high resiliency. So now it is very easy to develop decentralized applications. So we can think of like these applications like regular applications with blockchain as being a kind of an operating system. So now it's key to understand like where we need to apply these decentralized applications, because we cannot use this everywhere. So some of the key guidelines that we arrived at are as follows. So one of the key thing is like because of this shared ledger, so we can actually come up with a decentralized application provided the need is for the shared ledger where multiple parties do not trust each other. So if there is a single organization, you never need to develop a blockchain-based application or a decentralized application. So in order to where we can apply blockchain, the key point that I want to make is like it needs to be a shared database where there exists a conflict of interest between multiple parties. So this indirectly implies that these apps can be applied if there is a cross-organizations are involved, where there exists a conflict of interest about the delivering the business value, where both have to collaborate with each other for delivering the end product, but at the same time within there exists a conflict of interest due to their competency or their IP and various other factors, so they cannot share some of those things. So there exists, because of this conflict, we can apply these blockchain kind of technologies. And the second one is the decentralized trust among the multiple participants who are going to update this ledger. Because here decentralized trust means like there is no single leadership, like multiple parties are going to arrive at a given decision by kind of voting. So the majority decision actually prevails. So this scenario will also help us to apply the blockchain. And also, since the infrastructure cost, the compute cost, and is involved is very high with respect to storing this data on these kind of ledgers, so we need to have the value of the data should be very high. Otherwise, ROI on the data will be not much. So we cannot use this kind of blockchain kind of technologies for every data to be stored on the ledgers. So that's why it should have a very high value. That's why we say like it should have an asset value which is backed, where a critical data has to be stored in these blockchain. So next is where we should not use it. As I mentioned earlier, like it should not be used in the cases where the traditional database meets the needs of the application in a kind of a web architecture framework, and even a scenario where single participant is going to update the ledger. So this case comes even if you have multiple clients, if they are all serialized through a single updater, so then you don't need a blockchain kind of a technology to be applied. Yeah, sure. Yeah. Then next is, and also in case of scenarios where we have all updaters who are going to trust one another, then also you don't need the blockchain. And also if they trust the third party, so you don't need it. So here we see use cases like typical use cases where it is applied across various industry verticals where we can develop a decentralized application which is leveraging the blockchain technology. For example, if you consider like health sector and where sharing of the medical records across different hospitals, and in case of pharmaceutical provenance, and in case of government land registry and various other applications and banking. So the blockchain is going to make an impact on various multiple industries. And here one of the key attribute among all these industries is mentioned below, like whenever there is a asset transfer and provenance is the key ingredient which is required in a given application, then you can use this. And also cross-organizational workflow is involved and multi-party auditing. For example, compliancy is needed, then we can apply in these verticals. It's not like every application in these verticals needs a blockchain. Only if some of these three key ingredient criteria is required, like we have to prove the asset. In case of supply chain management, in case of manufacturing sector, where we have to track the asset, the part getting manufactured by different units and different organizations, where we want to prove the quality is good for the end customer. So now I'm going to talk about the specific instance of DApp architecture. Just as I've mentioned, like it's typically web-based browser where you have the client and server kind of a traditional way, where the backend is distributed and it is spread across multiple nodes. And this gives an application which is built on a blockchain-based decentralized platform. And so here it's mainly an Ethereum. Here sometimes what happens is the DApp web browser can directly interact with the blockchain. For that, there exist packages or there exist libraries, which they call it as MIST or something, where inside the browser itself you have some kind of simulated the blockchain node being present and which can interact directly. Whereas for some of the applications that we wanted to do inside the web browser, in the web server, there actually we use this kind of architecture. Here Web3.js is in case of Ethereum is a library interface that going to interact with the blockchain. And here there is a concept of smart contract exists. A smart contract is nothing but actually is the business logic. So that is going to run inside a blockchain. So blockchain is actually going to give a runtime execution environment, which is something similar to, which is called as Ethereum virtual machine, where the business logic can be coded. So as the transaction happens, the validator as a part of execution of the smart contract will be done as a part of the validation of those nodes. So as the new transactions being created and which are validated by the third-party nodes, which we traditionally call miners. So when they execute the transactions, they are going to execute the code. And this code is going to change the state of the blockchain. So that data will actually be replicated across the multiple nodes which are present, which will bring all the resiliency and the immutability aspects. So here we can see as the web server, the backend server, which is going to interact. So RPC is the way so that it uses JSON RPC so that any request that is coming from the backend server, it is actually going into the smart contract. Actually, the smart contract provides a way of reading and writing into the blockchain and also the execute the code. So while the smart contract which runs on a given node, its state will be replicated across. Now, any business logic that we wanted to come up with, which meets all those earlier described criteria, can be developed as a part of the smart contract plus the Node.js or the backend web server framework. This together forms the decentralized application. So these are typical decentralized applications that are available, which is open source. This is a website. So there exist multiple dApps that are being developed. Some of them are developed for fun and some of them are for much serious nature. And also these exist in various sectors and various categories. And some of them are open sourced and Some of them are closed ones. And all of these make use of Ethereum as a base platform for developing this application. So typically the smart contract or the business logic typically used to be a very small set of code, and the impact of this code is very high, in the sense like, since this code is going to be executed on multiple nodes, we can get a very high level internet kind of scale kind of applications being realized with high resiliency and with trust. So one such an example in decentralized application is like, even with as few as like some 30 to 100 lines of smart contract code, you can come up with the entire voting system for elections. Because since this code is executed, and which will ensure the immutability in every node, so which we cannot be tampered, because of that simplicity, it is able to scale well and provide the values. So coming to storage dApps, so there exist some of the storage dApps were developed. Here Storj and is one of the key example of it. So what they do is like, they try to leverage the public blockchain, where try to take the storage from individual disks of different nodes which are hosted, and they are incentivized by some kind of cryptocurrency for consuming those resources. So given data, given file, it's a kind of a peer-to-peer storage, where given file or the data is encrypted, and which is distributed across multiple nodes who are participating. So the participating nodes are incentivized, so that's why the public nodes can participate in this infrastructure. Here one of the key aspect is like, only the owner or the user of the data knows actual spreading of the data. So it means like where actually the shards of the data is present in those multiple nodes, and which is actually protected through PKI. PKI means the public key encryption system, so that the blockchain leverages for its identity. So because of the private key, they only able to, as I used like a credential, the user of the data, sorry, the owner of the data can only see the shards and leverage the distributed hash table which is actually present in the smart contract to contact those individual nodes and get those data which is aggregated together. So coming back to our interest, actually the public blockchain is not so much interesting for our enterprise world because of various reasons such as the privacy concerns and the IP leakage issues, and also in terms of functionalities, the performance and the scalability aspects. So because of this, we try to simulate a public blockchain kind of thing in a hosted cloud environment or in a data center, which we call it as private blockchain or a consortium blockchain. A consortium blockchain is a kind of a blockchain where multiple organizations come together, where the nodes or the computer is spread across multiple hybrid cloud kind of environment. Where only the limited set of users, unlike any public can enter, limited set of users are involved in realizing this implementation. So this is one of the DApp architecture that we developed in NetApp to see like how we can leverage the blockchain technology for some of the storage applications that we develop as an end user application for internal consumption purpose. Here one of the key thing to note is the DApp, which is developed as a microservice here, which is shown. This microservice contains several components, and this will interact with the blockchain with the same JSON RPC protocol, and the smart contract, everything has been deployed into the blockchain in a same way as if it is normal way of deployment outside in case of public blockchain. So one of the key aspects of this decentralized application microservices is basically this can be run even on either on public blockchain. This can be replaced the entire block where I'm showing like Ethereum blockchain on AWS, Azure, or public. It can be replaced because as this decentralized app is going to convert the request into the protocol that is expected by those individual blockchains. So it makes it totally independent. So this decentralized app can be hosted. So that's one of the flexibility that we get. And tomorrow we can replace this Ethereum with Hyperledger kind of blockchain also. So here, as we see, like from the client or the consumer of this service, which is hosted like a service where they regularly interact with the REST APIs. Here, obviously, these DApp instances will be multiple because to provide high scalability, that's why we have some kind of reverse proxy or a load balancer to receive those requests and spread across, and everything will do the same work. And this DApp need not have to interact with a single node as shown in here, Ethereum client 1. It can connect to any of the client nodes, because once the interaction happens, the record which enters into the blockchain through our smart contract business logic, the data will be replicated internally by the blockchain framework. So that will take care. Even if we do ingestion of data into the one node, so it is up to the blockchain protocol to take care of ensuring the immutability aspect and distributing the data. Distributing in the sense like replicating the data. So here we have introduced message queue framework because blockchain by default is a little slower. In order to ensure better performance for our application needs. So once the request come to the web server, so we actually queue it through RabbitMQ, and the backend will actually take it and push it to the blockchain framework. And here one of the key requirement is providing a multi-tenancy, because we will be tracking whatever the data which is being ingested into the DApp framework. We should know the identity. So we wanted to actually integrate with the identity mechanism that is existing. So here for the HTTP based request, we go through bearer token Auth0 authentication protocol. So once it is validated, authenticated, then we also bring in internal identity conversion mechanism in such a way that the blockchain has got a public private key based identity. So we want to convert those identity into what the blockchain understand, which is in Ethereum they call it as a concept of accounts. So the conversion is done through one of the microservices which is called as user ID to public key mapping. It's not actually a public key, it's a Ethereum address. So this conversion is done internally inside our DApp as the request comes. So we should be able to actually track from the user from the beginning of the IO request till they have ingested, so that later when we can do the auditing or we are going to verify the correctness of the data, we can figure out which set of users or who has modified the data. So this authentication protocol, which is integrated with the decentralized application framework, actually helps. So these are some of the performance results that we got out of our DApp instance. Initially we used the blockchain with proof of work kind of a consensus mechanism that uses to establish that trust. So in case of blockchain with proof of work kind of mechanism, here RPS means it is called as request per seconds. So that is a number of requests that we are ingesting into the framework. We got a very huge latency because the blockchain has to do a lot of compute and replicate and achieve this performance. So because of this bad performance, we switched over to another consensus mechanism which is present inside, which is called as proof of authority, where the identity of the user is used as a reputation for actually validating those transactions. Along with the message queue framework, we were able to get 5x improvement in performance, like it suddenly jumps to 20 requests per second with a reasonable latencies. And these are the configs that we use, like in case of config, 5 blockchain nodes, that's typical, where hosted on AWS with so many CPUs. So the key idea is like Ethereum is going to come up with next consensus algorithm called proof of stake, which is Casper programmers, which is called, and which will be having a better performance than current one. So currently the proof of work kind of mechanism that is used inside a blockchain it prohibits or inhibits lot of applications that we can develop over Ethereum framework. So some of the key takeaways out of this application is one is because this is evolving like a distributed ledger technology is actually a disruptive technology which is applicable across various industry sectors that we see, and the public blockchain through our experimentation and also various sources we find like it suffers from scalability issues, and unless and until they change the consensus mechanism to proof of stake kind of a software based authentication mechanisms, we won't be able to get better performance, and hence the adaptability will increase in future as it is going to be changed. And what our internal implementation we figured out, like we cannot use multiple nodes because the same state being replicated across multiple nodes. Because of that, we recommend not to use more than 5 nodes in a private or hosted blockchain setup. And also the application consumption requirements like not more than 30 requests if it's Ethereum kind. So we can scale better if we use other enterprise blockchains such as Hyperledger for a better performance for the applications. So any questions on this I can take up? Yeah, okay. So let me explain that. So what happens is the versioning is provided inbuilt. So that's the key aspects of blockchain. Because in the case of blockchain, whatever data is ingested into the framework, it will never go, it is immutable. Because of the immutable nature, the old data will never be deleted. So what we have implemented is like, since it is going to store those records, our smart contract is intelligent enough to recognize those multiple records whose keys were same, so that we can track, and whenever request is made, it's just simply taking from the blockchain those records and displaying it. So the versioning as internally, it comes by free. So just we have to identify those key metadata items and then retrieve them. So that's the idea. Yeah. Actually, the data is not visible in the sense like since we have brought in the authentication mechanism here with connected to the identity, so it will prohibit. So and also we don't use recommend use public blockchain. Of course, we can run this on public blockchain. Only thing is we need to come up with another microservice which involves actual cryptocurrency to consume the infrastructure of public. Yeah, sure.
Just curious to know, so you talked about Ethereum-based blockchain, right?
Yep.
Now, and you said it's a private blockchain. Doesn't it make sense to go with Hyperledger Fabric because finality is instant? Number of transactions per second is more than what Ethereum can support. And also, when you talk about scalability, you can have single organization, multiple nodes, and right. And you also said you use proof of work. So why would I use a private application when I need to spend ether on gas, when I don't have any kind of an incentive on a private application? It makes sense on a public, when you are having an ether spent.
Yes.
Right. So just curious to know.
So the question you're asking is how is it relevant for the enterprise world or a private blockchain,
No,
right?
no. My question is, why Ethereum? Why not Hyperledger?
Okay, sorry, I didn't mention that. Actually, we are working on Hyperledger because we got into Ethereum primarily because of the fact that the smart contracts are easy to write, so that we can bring our application logic quickly. So Hyperledger is the way to go because it provides better performance. And also in this kind of environment where we hosting like a private blockchain, right? Cryptocurrency doesn't have any value. Like we have those pseudo currencies. Just for the keeping the protocol happy, we create those gas and use it internally.
So yeah, so I think that you kind of took care when you use the POA, because POA doesn't kind of use any gas-based
Absolutely.
transactions.
Yeah. Yes.
So even so probably one other approach would be to use Hyperledger, which supports the Ethereum EVM, so that you can run your smart contracts on Hyperledger, so you can probably get the best of both worlds.
Yeah, actually we are considering two approaches. One is, as you suggested, the mixed one. To get a pure performance, we can run directly on a Hyperledger which uses the practical Byzantine fault tolerant consensus algorithm, unlike proof of authority. So that should give, and also another aspect about Hyperledger is like, it's not like if the data is ingested, it need not have to replicate among all the nodes. So that is giving a kind of high scalability there. So we need to just have a concept of chains. So multiple blockchains are a part of those Hyperledger framework. I think we can use completely different from Ethereum. So the key idea here is the DApp will remain same. So some of the pluggable modules will come here, so which will interact. So we can give a choice like, it's a kind of a template choice where if the customer is interested in which blockchain he wanted to go as a configurable parameter at the beginning of a deployment, they can select, and based on the performance expectations that they are going to have. And also Ethereum is also working seriously from past 2 to 3 years on improving their consensus algorithm, which is a proof of stake, which is not yet realized. So they say like they will give 10,000 requests per second. So we are also waiting. At the same time, we also give other choices like Hyperledger.
Maybe you can try EOS, which claims to be 1 million transactions. Yeah. Anyway,
Yeah,
thanks.
I think we need to see that whether we want to use EOS. So currently it looks like we will never be going for a public blockchain. So we try to be either consortium blockchain or a private one. So that where we can share the data only with the organization, means only one-on-one between NetApp and another organization which is interested in shared ledger between the two. Okay, thank you. So,